So, hello, I'm here to demonstrate how a SAP-1 computer works for tasks 1 and 2. So, for the task 1, we are asked to write a SAP-1 program which solves the problem 25 plus 30 minus 11. So, first, we convert the decimal values into their corresponding hexadecimal values to use in the assembly program. And next, the assembly program is created, which is shown in this table. And the tabulated values are the ones we will input in the SAP-1 Simulator. So let's go to the SAP-1 Simulator. So first, let's add a new program and use this table for the values we will input here. So first, we can input the values here, and we load first value, then add the second one, and subtract the last one. And then we output the answer, and after that, to stop the program, we will use the halt instruction. So as per the instructions, the data is to be stored in addresses DH, EH, and FH. So we'll input the values there. The values are 25, 30, and 11. So we'll use the add and load instructions for the values. We use add because it is higher than 16 bits, and load if it's below the 16 bits. So you'll see. So the corresponding hexadecimal of 25 is 9H. So we input 9H, and we can see that its value now is 25. Hexadecimal of 30 is EH. So we can see that the value is 30. And the last is 11, which is BH. So we can see that these are the values 25, 30, and 11. So lastly, we'll assign the addresses of the values. So first is DH. So we input DH, then EH, then FH. And now we will apply changes and close. We will save it. So let's run the program. So but starting starts with the program counter, which stores and sends out the memory address of the next instruction to be fetched and executed, starting with 0000 and increments by 1. And then next, the instruction is sent to the MAR, which stores the 4-bit address of data or instruction which are placed in the memory. Next, the instruction is then sent to the RAM, which starts the read operation, and to the instruction register, which receives and stores the instructions placed on the bus from the RAM. And then the address and the instruction is then sent back to the MAR for the second instruction. The program then sends the value to the accumulator, which stores intermediate answers during a computer run. So next. Now on to the next instruction. The RAM then the RAM reads the value and sends the RAM reads the value and sends it to the B register, which supplies the number to be added or subtracted from the contents of the accumulator to the other subtractor, and which it sends to the other subtractor for the addition process, and the resulting value is then stored back into the accumulator. So upon adding 25, 30, we get 55. So next, program executes the next instruction, which is subtraction, and the process is the same. The values are stored here, and the RAM reads the value and sends it to the B register and into the other subtractor for the subtraction process, and the value is stored in the accumulator. So next is the output instruction. So this only outputs the final value that is in the accumulator. So upon executing, you can see that the answer is 44. Next, and after that, program executes the whole instruction and it stops the program. So that is all for task 1. So for task 2, we are tasked to write a program which solves the problem 10 plus 8 minus 5 plus 7 minus 4. So first, we'll find their hexadecimal values and the assembly program, the tables. The tabulated values are used for the simulator. So let's go to the simulator first. Let's create a new program and let's input the instructions. So instructions are: first, load the first value, then add the second, subtract, add, and subtract. So load, then add, then subtract, then add, then subtract. Then we output the answer. Then halt the program. So, and as per the instructions, the values are to be stored in the address BH2 FH. So the first value is AH. We'll use the hexadecimal values. So use this to load the values. So first value is AH, then 8H, then 5H, 7H, and 4H. Then we assign the address, so where it gets the values per instruction. So first value is PH, then CH, then DH, EH, then FH. So let's apply, save, then let's run the program. So the first instruction, say this, the whole process is the same as the first task. So first instruction is just to is sent to the MAR, then to the RAM, where the instruction is read and is sent to the instruction register. Then the first value is stored in the accumulator. The next instruction, which is addition, is executed. First, the RAM reads the value, and the value is sent to the B register and to the other subtractor where the addition process is executed. So 10 plus 8 equals 18. So the answer is sent to the accumulator. The next instruction is executed. So this one is the subtraction. So first it loads the value. Then the RAM sends the value to the B register and is sent to the other subtractor. So 18 minus 5 is 13. So the answer is sent to the accumulator. Next is addition, and so on and so on, and subtraction, and lastly the output instruction is executed, which outputs the final answer, which is 16, and the last instruction, which is halt, which stops the program. So that is all. Thank you.